Today we're going to talk a little bit about section 5.5 as well as a little bit of 5.6. Parts of 5.5 we're going to skip over. We'll see what we can do here. So we're going to talk about continuous random variables now. So remember, continuous could be, it's not a set number. Like discrete was, it's either you're a size 8 or 8.5 or 9 or 9.5 shoe, right? But a continuous could be any number. Like your foot could be 12.125 inches long, right? Okay, so it's a continuous sort of thing. So here we have kind of a graph of a discrete, right? We have some different scores. Now, what a continuous does is it kind of takes some of these numbers and it takes it and kind of evens it out. So it kind of this is called a density curve. Okay, so this density curve takes some things and makes a smooth curve out of it. So the probability of the definition is a density curve. It's always on or above the horizontal axis. Okay, so we have our line here, and we sort of like on a number line. And the area underneath it, okay, we have 100% of our data. Probability is of 1 underneath it. Okay, the normal curve is what we're going to use mostly. That's the density curve we're going to use pretty much all the time. Okay. We've talked about this in the past as well, the mean and the median of a density curve. Okay, so if you think about the mean is sort of our balancing point. So if you're going to put think about all this area here versus down here, this would very much outweigh it, right? And if I put it here, it outweighs it. But if I have it right here, it kind of balances both sides. Okay, so that would be where our mean is. It's our balancing point. And your median is, it's halfway through, right? So it's at the 50th percentile. So it's halfway, divides them in half. So if you think about something that's skewed, well, let's think about if it's symmetrical. We know our mean and our median are both at the same point, right? And we had said earlier, if it's skewed, it draws the mean farther that direction, right? So our mean would be farther down towards the skew versus the median. Okay, so if you look at this here, which do you think would be the mean and which do you think is the median? Okay, so we can see a slight skew to the left here. So what's going to bring it this way? Okay, the mean is going to be brought this way a lot more, so your mean is BA, and your median is brought just a little bit this way because there's a few more numbers. The median would be B. Okay. So the one that we're going to be talking about a lot today is the normal distribution. Okay, so a normal distribution is symmetrical. Okay, and it's got a smooth bell curve to it. So when you define a normal distribution, we're going to look at we can look at this here. So they have a bell shape. Okay, so they all have a bell shape to them. They're single peaked in the middle. They're symmetrical, and our mean and our median are pretty much always the same thing. But we don't really use median when we're talking about the normal curve. We're going to talk about mean and the standard deviation. Okay, so the mean is always in the middle here. The standard deviation is how spread out it is. Okay, so you notice this one's more spread out, so it would have a higher standard deviation, the average distance from the mean, right? And this one here is the data is more close to this mean, so it's going to have a smaller standard deviation. Okay, but what we want to do is look at its mean and its standard deviation and be able to draw this out. Okay, so this is how we're going to draw it out. So we'll just say X is the reading scores on a 7th grade reading test. Okay, so what we're going to do is we're going to start by drawing our bell curve. Okay, the middle of that bell curve is our mean, okay, the 6.84. And then what we're going to do is we're going to go 3 standard deviations away. So 1 standard deviation above, 1 below, 2 standard deviations above and below, and 3 standard deviations above and below. Okay, and the way what we do to fill these numbers in is we add our standard deviation in this way or subtract it this way. So if I take my mean, 6.84. If I'm 1 standard deviation above, I'm going to add 1.55 to it. So I get 8.39. And if I'm 2 standard deviations away, I'm going to add another 1.55 to it, another standard deviation. I'm at 9.94. And if I'm 3 standard deviations above, I'm going to add it in 3 times. So add another 1.55. I get 11.49. Okay? So adding in how many standard deviations? I'm 1 standard deviation away. I'm 2 standard deviations away. I'm 3 standard deviations away. Okay? Now, to fill out the other ones, I want to subtract. Okay? So I'm at my mean, 6.84. I'm going to subtract 1 standard deviation away, 5.29. So I'm at -1, -1 standard deviation. I'm going to subtract 1.55 again, 3.74. I'm at 2 standard deviations away. And subtract another 1.55. I'm now at 2.19. I'm at 3 standard deviations away. Okay, so this is the actual score. This number right here is called the z-score, and we're going to work more with that on next week on Monday. But this is the z-score, and this is how it corresponds. Okay, so if I would have a score halfway between here, I would have a z-score of 1/2. And if you remember, we did z-scores a little bit in the past. Z-score is how many standard deviations away it is, right? Remember we did our x, our number, minus our mean divided by standard deviation? Okay, we did that earlier this year, thinking about how many standard deviations away it is. So if I'm at like 9 would be somewhere in here. 9 would have a z-score of 1.6 or something, 5 or 4, I don't know, whatever it is. Okay? Yeah, so that's how we draw it out. So let's do another example. So let's take this one here. Let's say a baseball player. A baseball player's batting average is the proportion of times a player gets a hit out of the total times at bat. So 3 out of 10 times would be an average of 30%. Okay. Suppose we select a Major League Baseball player at random. X is the player's batting average. The probability distribution is normal. Okay, so we know it's normal, so we can draw this out. You'll get better at this the more you draw them. Okay, they're not always the best drawings, but that's okay. It says it has a mean of 0.261, and the standard deviation is 0.034. So go ahead and pause the video and find 1, 2, and 3 standard deviations away. Okay, to find these distances, right? 1 standard deviation above would be 0.261 plus 0.034, be 0.295. Add another standard deviation to it, it'd be 0.329, and add one more standard deviation to it, it'd be 0.363. Okay, z-score of 1, z-score of 2, z-score of 3. Okay. Below, if somebody's below average, okay, we're going to take the 0.261 minus the standard deviation, 0.227 minus another standard deviation, 0.193 minus one more standard deviation, 0.159. Okay, z-score of -1, -2, and -3. Okay, this is the actual batting average, this is the z-score. Okay, that's all of 5.5. Now 5.6, we're going to start in defining some probabilities. And we're just going to do the beginning part of it here. If it's a normal distribution between these two, if I'm 1 standard deviation away, we have 68% of the population in there. So for example, some people believe on grading on the curve, and I've actually some college professors and stuff do this. We don't really do this in high school, but anyway, college professors within 1 standard deviation, okay, they take the whole class and all their averages, and if somebody is within 1 standard deviation, they get a C. Okay, 68% of the people are average. 68% of the people would get a C. Okay, Within 2 standard deviations, we have 95% of the people. And these people would get a B, these people would get a D. And within 3 standard deviations, it's almost everybody. It's 99.7% are within 3 standard deviations. So from 3 standard deviations from there to there, we have 99.7% of the people. Okay? So here, thinking about batting averages for baseball players, 68% of the people in Major League Baseball will hit between 227 and 295. 95% of the people hit between 193 and 329. Okay? And between these two, we have 99.7% of the people within there. Okay? So let's break this down according to each individual section. Okay? So if I think about this, if this is 68% here, right? If I have 68% in there, that means I'm going to have 34 in this section, and I'm going to have 34 in this section. Okay, so 34% of the people are within 1 or negative 1, right? 34 here and 34 there. Okay, the next one, for here, if I want to find out what's in each of these sections. So if I want to know, if I take 95%, right? The whole thing here is 95%. If I subtract this 68% away, okay, I get 27%. So there's 27% here and here. And if I take that and divide by 2, that leaves 13.5% for each of these areas. Okay? We can use the same logic for the next. Okay, if it's 99.7% of the people between here and here, so take this middle part away, which is 95%, and divide by 2. Okay, I get like 2.35% here, 2.35% here. Outside of this is only 3%, right? So I have 0.15%, not even a percent, right? 0.15% on the outside areas. Okay, so for example, when you get a if you are you're pretty special if you are in like above 2, right? If you're above 2, like say you're taking a SOL test or an AP test or you know, I don't know, SAT test or your height or whatever. If you have a z-score of 2 or more, you can see that there's not many people that fit into that category. Okay, and actually they use, I think, I'm not sure exactly where it is, but in some tests to classify you as somebody as like mentally retarded, they have, you know, they score down in this area down here, so a certain percentage. So how you do on certain tests. So let's look at a problem with this. Okay, so we had drawn this out already. So if we take this, the 7th grade scores, okay, we had our mean here with a standard deviation here, and we had drawn that out earlier. Okay, so let's find this. What's the probability that x is less than 3.74? Okay, so here's 3.74. Whoop, I gotta move this down a little bit. Okay, x is less than 3.74. Here's 3.74. We want to know this probability right here. We want to find this area right here. Okay, and we had said that it is 2.35. Okay, 2 standard deviations and 1.15. So if I take the 2.35 and add it to the 0.15, this area right here is 2.5. So this area right here is 2.5%. Okay. So we're going to use this chart here. You might want to write these down. So if we're here and we know it's greater than that, you would add all these probabilities together. If it's here, we want to find all these probabilities together. That sort of idea. Okay. Okay, so next one, part B. What's the probability that their score is between 5.29 and 9.94? Okay, between 5.29, okay, so that one's this one right here, and 9.94 is this one right here. So I want to find this area right here. Okay, so that area there. So if we look at our thing we made here, we know it's 34 and 34. So this one here is 34 and 34. And this one here is 13.5. So the probability that somebody's going to score between those two scores, I have to add those together. And I get 81.5%, or 0.0815. Whoop, 0.815. Okay, so the probability that somebody's going on this test is going to score between this score and this score would be 81.5, the probability of that happening. Okay. Yeah, I think that's where we're going to stop today. So in the homework, I'm going to have you put these numbers in and find some of these probabilities here with it. So make sure you have this and you have that down and you understand how do we find those.